statistic. So in the last class, we have also discussed about the random sample. So any quantity Mr. Venkata, if you can see the question paper of regular mid semester EC2 regular, so you can see only I gave the normal distribution and the geometric distribution. First question was the general probability. Second question for the Bayes theorem, conditional probability. Third question related to the probability mass function, simple. So in one question only you can say, okay, you are not able to identify the distribution. In the last question, it is already mentioned that it is a normally distributed random variable. In the second last question, was the probability density function for the continuous. Only I gave you the formula based questions, concept based question. So only one question we can say which is not mentioned that it follows the geometric distribution. Otherwise, all questions are very much clear. And all questions that I have given, that there is no need to remember the so much formulas. Only concept you have to know now. Okay. So now we start statistic. So in the statistic, that is the quantity whose value can be calculated from the sample data. So any function of a sample data is known as a statistic. Okay. And in the statistics, it is also be a random variable. So that part we have already done. I am just repeating it. Denoted it by the uppercase, and lowercase will represent the calculated or observed value of that statistic. Okay. So important statistics, as I told you, that is the sample mean, and it is what summation of xi divided by n. N is what? The size of the random sample. So we are just taking here x bar. We can write like x bar is equal to summation of xi, I is equal to 1 to n upon n. So that we have already discussed in the last class. Sample mean. We have also discussed about the sample variance, that is denoted by the s square, which is summation of xi minus x bar square whole square divided by the n minus 1. है ना? Expected value of x bar is equal to mu, and variance of x bar is equal to sigma squared by n. And expected value of s square is equal to sigma square. So now there are two things which we want to discuss here. First is x bar. It is a statistic. It is a random variable. So if it is a random variable, it has some distribution. And if it is having the distribution, so we can find out the expected value of x bar. And that is equal to the mu. Mu is what? Mu is the population mean. So there are two type of mean we are discussing here. The sample mean, that is x bar, and the population mean, which is mu here. Okay. So expected value of x bar is equal to mu, and variance of x bar is sigma squared by n, where sigma square is what? That is the population variance. Okay. Similarly, s square is also be a function of the random data, random sample. So that's why we can also consider it is a random variable. It is a statistic. So its expected value is equal to the sigma square. Correct? So these are the different you can say the statistic which we are using from the random sample. One is the sample mean. Second is the sample minimum. Third is the sample maximum, the maximum value of that sample. Fourth is the sample range, that is the maximum to the minimum of the sample. And the sample variance. Sample variance we have already done. So one example if we are taking here. So there is a sample of size 9. So n is equal to 9 here. The sample data is given here. Now from that you can identify the sample mean, that is the summation of xi, that is 3675 divided by 9. So it is coming 408.3. Okay, billion tons. Next is the maximum. So you can see the maximum of this is what? Is 4105. So that is known as the sample. Sorry, it is not 415, it is 450. So that is known as the maximum, sample maximum. Okay, and what is the sample minimum? That is the 390. So 390 is the sample minimum, 450 is the sample maximum, 408.3 is the sample mean. Okay, similarly we can find out the another example. In this example you can see again n is equal to 9. This is the another data points, and in that data points you can see here we are arranging this data points, and we can say again the sample maximum is 450, minimum is 390. Correct? The same sample data, only we are rearranging it, and the sample mean is we have already calculated is 408. And in the last class, in the last slide, 408 point, what was the answer? 408.3. Okay, now we can calculate the S square, the sample variance. So we calculate the summation of xi, summation of xi square, substitute in the formula, and it is coming 303.25. So just a formula based thing, and there is no need to remember the formula as well, because the EC3 examination is open book examination. So there is no need to remember the formulas here. Next is the sample standard deviation, that is denoted by the capital S, and that is the square root of sample variance. So it is 17.4 million tons. Okay, so variance is always unitless, where the standard deviation having the same unit as the x has. Okay, so the physical measurement unit associated with S matches that of original data, and that is 7.4 million tons is the standard deviation of this sample here. Correct? Any doubt, any query in this one? So these are considered as a sample statistic. Any formula of random sample is considered as a statistic, and that statistic always be a random variable. Okay. What is the formula? What is the formula for S square? S square formula is what? Summation I is equal to 1 to n xi minus x bar whole square divided by n minus 1. Then we can use it in a different manner. So it is coming like n summation of xi square I is equal to 1 to n minus summation of xi, I is equal to 1 to n whole square divided by, I don't know what is happening, is n minus 1. So these are the two formulas of calculating s square. You can use any one. Okay, Mr. Vineet? So we have already done about the random sample. No, we always use n minus 1. It is below 20 or above 20 only. That we will discuss later on. That is the finite population and infinite population, which is given here. So if small n upon capital N is greater than equal to 0.5, 0.05, we consider is finite population. So at the time we are taking as small sample. Yes, Mr. Venkata, we will discuss it later on, biased and unbiased deviation. So here we are taking unbiased deviation. That's why we are taking in denominator as n minus 1. Okay. And Mr. Vineet, we are calculating xi minus x bar because xi, you know, like for example, 309, 309, 381, like x bar is coming here 408.3. So you can say 408.3. Correct? So if we have the finite population, are the slides moving? Are you getting my point here? No. Slides are not moving. Just wait. Maybe I am on the mean and variance of sample mean. Maybe I will check the connection. It may be due to the some Am I audible? Okay, fine. So it means I will rejoin my tab. Maybe there's a problem in that one. Now the slides visible. Are the slides visible? Mean and variance of sample mean. So if we have the finite population, means what? Small n upon capital N is greater than 0.05. So that is the variance standard deviation of the X bar. But when it is in finite population, we consider it small n upon capital N is less than equal to 0.05. At a time, we can say here sigma upon root n. Okay. So we in the last class we have done one example, and we have taken the 2500 managers. Out of that, we have taken the 30 managers as a sample. So it is less than 0.05. So it means what? Capital N is the population size. Capital N is the population size here. So mu x bar is this, sigma x bar is this, sigma upon root n. Okay. So because it is, we can consider as infinite population. But if we are taking small n is very large, like 1500 or 1000. So at a time, it is not like point less than 0.05. So we have to use the upper formula actually to calculate the sigma x bar. But the mu of x bar is the same for all the cases here. Okay, so one example we are taking, let x1, x2, x25. So n is equal to 25, a random sample from an infinite population. So it is given in the question, it is an infinite population, means n is very large. Okay, so having the mean 10 and variance 50. So it is given that mu is equal to 10 and sigma square is equal to 50. Find the mean and standard deviation of x bar. So we know that expected value of x bar is equal to mu. So that is equal to what? Mu is equal to 10. So it is 10 here. And variance of x bar, we have already know the formula. It is sigma square by n. So sigma square is given as 50 and n is equal to 25. So that's why it is equal to the 2, and sigma x bar is equal to square root of 2. Correct? Next is x bar plus 5. X bar is of x bar plus 5. So how we can do it? That is, we can say expected value of x bar plus 5. Correct? Now expected value of x bar is already, we know that it is 10 plus 5. So that's why it is become 15 here. And variance of x bar plus 5. So variance of, it is equal to the variance of x bar only, and that is 2. So standard deviation is square root of 2. No change at all. Okay? The next one, can you do it? Expected value of 7x bar plus 5. So what we will do? 7 times expected value of x bar plus 5. So that will become what? I am just writing here because at the time the 7 expected value of x bar plus 5. So that is equal to the 7 multiplied by 10. So 7 multiplied by 10 plus 5. So it is equal to the 75. Okay. Now variance of 7. I don't know, the pen is not working properly here. That is what? 7 square. So we are taking 49 variance of x bar. Plus 5 means what? Variance is equal to 0 in that case. Okay. So we can say 49 variance of x bar we have already calculated 2. Got it? So 49 multiplied by 2. That is the variance of 7x bar plus 5. We are taking the square root of it. That will give you the standard deviation of 7x bar plus 5. Some more practice problems you will just see it and you can solve it. Correct? The next term is the central limit theorem. Just give me a 1 minute only. Sorry, I'm not well. That's why I took the break. 7 is the square, 49 came, that is the square of 49, 7. 7 is square. Just see the previous slides in the variance. So we are taking variance of ax is equal to a square variance of x. So it is 7 of x bar. So that's why 7 is square variance of x bar. Okay, Mr. Vineet? Now, important theorem which we are discussing here, that is the central limit theorem. Am I audible to all of you? Thank you. So central limit theorem is a very important theorem actually related to the statistics. So in which one, what we are saying, whatever the distribution of a population, okay, regardless of the population distribution model, the sample size increases. Means what? N tends to infinity, then sample mean tends to be normally distributed. Okay, that is very important here. Okay, so what we are saying, if xn be a random sample, size n of size n, and for large n, the sample mean, that is x bar, is approximately normal with mean mu and variance sigma square by n. Okay, so you have done so many questions of the normal distribution. So after that central limit theorem, we reach to the questions of the normal distribution. How we solve the question of the normal distribution? You have done the last question of the normal distribution. So what we are doing, we are just converting into the standard normal distribution. But by x bar minus mu upon sigma upon root n, it follows the standard normal distribution. And by using the table of a standard normal distributed, we can find out the different type of probabilities. Okay. So here we are using this apply the central limit theorem step by step. First is we have to identify what is the mu, what is the sigma, what is the sample size n. Okay. Now what type of probability is provided that find x bar in terms of greater than or less than whatever the probability is provided, then we can say the x bar follows the normal distribution, and then we can convert it into the standard normal distributed random variable, and by using the table we can find out the value of the probability. Correct? So one example we are doing here, a certain brand of the tires has mean life 25,000. So what is given? Mu is equal to 25,000 with a standard deviation 1600 kilometers. So sigma is equal to 1600. What is the probability that mean life, that is x bar, of 64 tires, means n is equal to 64, is less than 24600. So it means what we are trying to find out, the probability that x bar is less than 24,600. Correct? Where n is equal to 64. So n is sufficiently large here because we have taken that n is greater than 30, then we can consider it large. Okay, so n is equal to 64 here. So we can say from that x bar by CLT, central limit theorem, we can say x bar approximately follows a normal distribution. Okay, with mean 25,000 and variance 1600 divided by square root of 64. Correct? So x bar follows the normal distribution with these parameters. Now we have to find out the probability of X bar less than 24,600. So X bar follows the normal distribution. So we can say probability of X bar minus mu upon sigma upon root n. So it will become a standard normal distribution. Both sides we will do the same thing. 24,000 minus upon 200. Correct. So that will become here probability of Z is less than. That is become minus 2. This calculation will become here. This is not 24, it is 25. Yes, Mr. Chatterjee. Mr. Miller and Mr. Chatterjee, EC2 regular exam is already done and the same syllabus is coming for the makeup examination. Same. Before the section 5.10 joint distribution. So joint distribution will not come into the EC2 examination. We are not changing the syllabus of regular to the makeup. Makeup examination syllabus is also same. I think this information is enough. So Z is less than minus 2 and by using the standard table, we can find out its value is 0.0228. Okay. So that type of question we are doing here. So whatever we are doing here right now, no, it's not 5.1. 5.1 will come. .028 is coming from the CDF table. Normal standard normal CDF table now. Okay. Another example, I believe that you can do it. So human pregnancies follows the normal distribution with mean 268 days. So mu is equal to 268 and standard deviation 11 days here. And the mean pregnancy length of 70 women. So n is equal to 70, so it's sufficiently large. So what is the expected value of standard deviation of this statistic? So it follows the X bar follows the normal distribution with expected value of X bar. We have known is mu. Mu is what given is 268 and variance of X bar is equal to sigma square by n. And standard deviation sigma square is what? 11 multiplied by 11 upon n is what? 70. So sigma of X bar is equal to square root of this standard deviation. So it is 1.314. Multinomial distribution will not come in the EC2 examination. Some more example, we are just saying here problem solving. So I will upload in the slides. You can see about this one. Okay. Some more examples we are doing here. So for the central limit theorem, and to find out the sample mean, median, mode, standard deviation, maximum, minimum, that you can do it very well by using the formula. Okay. Now we are doing the statistical inference. In that one, what we are doing? We are just finding the parameter actually. So we are using the statistic to estimate the population parameter. That is known as the statistical inference. Okay, so we have to just keep just a minute. I will see what image you have sent me. Just wait. No, probability density will also come. 5.1, 5.2, that will also come. The red part is also coming. Where is the multinomial distribution here? The red part will also come. That will not come. Joint distribution, discrete and continuous, that will not come. That is the 5.10. So the three things you have to keep it in mind when we are doing the inference. A sample is only the part of the population, so that will not give exact value of the parameter. First thing, not the exact value of the parameter. Second is the observed value of the statistic depend upon the particular sample selected. So if we change the sample, the value will also change. Variability in the values of the statistic over different sample is unavoidable. We can't avoid it actually. So these are the three important things. Now we are doing here three type of inference. One is estimation, point estimation, interval estimation, and third we will do the hypothesis testing. So what is the point estimation? We are just estimated by the single value for unknown mu. For example, we are saying it is x bar. X bar, you know, sample mean. Interval estimation, we are finding the interval of plausible values for mu. And typing of a hypothesis testing, determine whether or not the mean mu is 170 MPa, which is a mean value of alternative material. Expected value of x bar is equal to mu in all cases. No condition required. Mr. Arjun, if we are just sending you the highlighted handout, that will create the confusion who have already given the examination. Mu is not equal to the x bar. Mu is not equal to the x bar. Mu is equal to expected value of x bar. That you know very well. Expectation. Okay. So we are doing the point estimation here. So statistic, which is a function of a random sample, is to use to do estimate the population parameter theta and call the point estimator for theta, and it is denoted by theta hat. So this is known as the point estimator, and its observed value is known as the point estimate for theta. Okay, so a point estimate of theta is a single number that can be regarded as a sensible value of theta. Correct? A point estimate is obtained by selecting a suitable statistic and by computing its value from the sample data. And that data is statistic is known as the point estimator of theta here. So which is the most important statistic? So X bar is used to approximate the population mean mu. Sample variance is to approximate the population variance sigma square. And S is used for sigma. So what it means what? That mu population parameter, its estimator, and its estimator is what? Estimator is what? X bar. Sigma square hat is equal to S square. Sigma hat is equal to S. So these are the estimator basically. Okay. The desirable property of the point estimation is what? Expected value of theta hat is equal to theta. That means what? It is an unbiased estimator here. Okay. And if there are two unbiased estimator, so we are just calculate the small variance. Okay. So we are seeing here is statistics theta 1 hat is said to be more efficient and unbiased estimator of the parameter theta than the statistics theta 2 hat. So there are two statistics basically, theta 1 hat and theta 2 hat, which is more efficient one. So we are just checking it is unbiased. Unbiased means what? Expected value of that is equal to the population parameter. If there are two, so what we will do? We are finding the variance of that estimator and then finding which having the small variance. Point estimation, after that we will do in later according to the your textbook. So I'm just taking a one more break. Actually, I am not well. I already told you. So I'm just want a small break again. Welcome back after a long break. I'm really sorry. Am I audible? Am I audible? Thank you. As I told you that I am not well. Just 2 days before I just discharged from the hospital. So having so much weakness. But I'm trying to complete your syllabus. That's why I'm taking a class. Sorry for that, for your disturbance. Thank you, Mr. Prashant. I'm trying. So we will take some more time and then we will. Okay, we will just take some more time. I will just tell you about the interval estimation. Thank you. Thank you. Thank you for your wishes. So as I told you that point estimation, that is a one single point. And we are just discussing about the unbiased estimator. And one more we will do later on. That is given in your textbook. We will discuss first about the interval estimation. So in the interval estimation, we are using the point estimate plus minus some margin of error also. Okay. So we are just trying to find out the margin of error so that we can find out the point estimate here. So these are the point estimate as I told you here. And then we are finding some margin of error. Okay. So that's we are doing here. First condition, when we are finding the interval estimation for mu, when sigma is known. So there are two parameters, mu and sigma. We are trying to estimate the mu when sigma is known. Okay. So in this one, margin of error must be computed either by the population standard deviation sigma or sample standard deviation S. So we are just taking the first case when sigma is known. So at the time we already told you when n is greater than 30, so x bar approximately follows the normal distribution by the central limit theorem, hai na? So by using that concept, we are using here that interval estimation. We are defining the interval estimation as probability of L1 is less than equal to theta is less than equal to L2 is 1 minus alpha. Okay. L1 and L2 some limits and theta is the population parameter and 1 minus alpha. So that will give the interval, this interval L1 and L2. This interval will give you the 1 minus alpha into 100% confidence interval. Got it? So this alpha is known as the level of significance and we are saying 1 minus alpha is known as the confidence level. And we are just talking about 100 into 1 minus alpha percent confidence interval. Correct? So this L1 and L2, this interval is the 100 into 1 minus alpha percent confidence interval we are talking about. So 100 into 1 minus alpha percent confidence interval is given by for mu. Okay. When sigma is known is what? X bar minus sigma upon root n, and it is also mentioned very clearly. Okay, it is not given here. So it is like this one. L1 is what? X bar minus sigma upon root n Z alpha by 2. Now that part you have done Z alpha by 2. Z alpha by 2, how we can calculate? Probability when Z is greater than Z alpha by 2, it is equal to the alpha by 2. So that is Z is what? Standard normal distribution. है ना? So we are using the same concept here, standard normal distributed random variable. And by using this, we can find out this value Z alpha by 2. And we can say L1 is what? X bar minus sigma upon root n Z alpha by 2. And L2 is what? X bar plus sigma upon root n Z alpha by 2. Okay. So this L1, again I am writing here, minus sigma upon root n Z alpha by 2. And L2 is equal to X bar plus sigma upon root n Z alpha by 2. So what is the difference? Only this plus and minus. And this is known as the margin of error basically. And this is, we have already known, that is the point estimator. Okay. So we are finding here X bar plus minus Z alpha by 2 sigma upon root n, and then we can find out the 100 into 1 minus alpha percent confidence interval. Okay. So in the standard normal distribution, we are saying here this is probability is 1 minus alpha. So we divide into the three parts. One is alpha by 2, second is also this alpha by 2, and this is 1 minus alpha by 2. So this point is known as the Z alpha by 2. This is the curve of standard normal distributed random variable. Correct? Most commonly used confidence interval is what? 90%, 95%, 99%. So when we are, sorry. So when we are talking about the 99% confidence interval, so what we are saying here, 100 into 1 minus alpha is equal to 99. So it means 1 minus alpha is equal to 0.99. Correct? So from that, alpha is what? 0.01. That is the level of significance. Okay? So it is 0.01. So alpha by 2 is what? 0.005. And that value is what? 2.576. That's Z alpha by 2 here. Similarly, when we are taking 95%, so this Z alpha by 2 is 1.96. Okay. So from the standard normal table, we can find out the value of Z alpha by 2. So if we are talking about the 95% confidence interval, so X bar minus 1.96. So that is what? Z alpha by 2 sigma upon root n. Similarly here, X bar plus 1.96 sigma upon root n. Okay. So this is L1 and this is L2 here. That is known as the 95% confidence interval for mu. So it is completely formula based questions. Now there is no need to remember the formula because it's a open book examination. Okay. So don't worry about it. It's very easy. It's only concept based. So we are taking a one example here. CI means confidence interval. We are doing interval estimation now. So that interval estimation is known as confidence interval. CI means confidence interval. Okay, Mr. Vineet? So one example we are doing. So by example, you can understand very well. Assume that helium porosity in percentage of coal sample taken from any particular seam is normally distributed. So it is given in the question, it is normally distributed with true standard deviation is 0.75. So what is given here? Sigma. Sigma is 0.75. Okay? Compute 95% CI. That is the confidence interval. So 100 into 1 minus alpha is equal to 95. 1 minus alpha is 0.95. So alpha is 0.05 and alpha by 2 is 0.025. So Z alpha by 2, we have already told you it is what? 1.96. Okay, in the last slide it was mentioned. Now what is given here? Average porosity for 20 specimens. So it is what another thing is given, n is equal to 20 and it seems was 4.85. That x bar is given as 4.85. So 95% confidence interval for mu is given by what? X bar minus sigma by root n z alpha by 2 comma x bar plus sigma upon root n z alpha by 2. All values you know, substitute in this one. So x bar is given as 4.85. So it is 4.85 minus 0.75 root n 20 into 1.96. Only the plug in the values in the formula. So check the two assumptions. Normality, yes, it is normal. Sigma is known, yes, it is given 0.75. Second, n is equal to 20, x bar is 4.85, sigma is 0.75. Step 3, z alpha by 2. Here we are just checking what is the alpha by 2. So it is 95%. So we are just calculating it and we are just reaching that it is what? 1.96. Then we are plugging the values in the formula and this answer is coming 4.85. So this is plus minus both ends and it is 0.33. So margin of error is what? 0.33 and that is 4.52 and 5.18. Now it's clear? So it's not so hard. There is not so tough. It is completely formula based. And it is completely based on the normal distribution. So you have to just again revise the concept of the normal distribution, standard normal distribution, and how to see the tables. Z alpha by 2, I just repeat it, Z alpha by 2. It is given here, and alpha is equal to 0.05, that is okay. Then alpha by 2 is what? 0.025, correct? Now we have to find out the Z alpha by 2. So here what we are saying, probability when Z is greater than Z alpha by 2 is equal to alpha by 2. This is the definition. We are using this definition, probability when Z is greater than Z alpha by 2 is equal to 0.025. So by using this table, Z is less than Z alpha by 2 is what? 0.975. So in the standard normal table, we are taking the 0.975 and that value is coming 1.96. Means what? Probability when Z is greater than 1.96 is equal to 0.025. This is the answer. Okay, Mr. Venkata? Another example, we have to find out the 98%. Yes, correct. Final value from the standard table. 98% and n is equal to 16 and x bar is 4.56. Same concept, okay? So check two assumption, normality, yes. Sigma is known, that is 0.75. Now what is given to us? N is equal to 16, x bar 4.56, sigma is 0.75. Okay? In this one, we are just mentioned the table also. So what we are saying? Alpha by 2, correct? It is 98. So alpha is become here 0.02. So Z alpha by 2, we are saying 0.99. 0.99 is coming here in the standard table. And this is corresponding to the 2.33. So that's why Z alpha by 2 is 2.33. Now you can plug in the values here. X bar minus 2.33 sigma upon root n. Similarly for X bar plus 2.33 sigma upon root n. And the answer is 4.12, 5. Now it's okay, Mr. Venkata. Some more examples. Please go through it. Same type of examples and some exercise also. So summary is what? I was just doing the summary and then I will leave. So what we are doing? Can the population standard deviation sigma is known? Yes. So we use this formula here. Okay. In the no case, that we will discuss in the next class here. I'm not able to sit actually. So that's why I'm just closing the class here right now. Okay. All the best for your examination for EC2 makeup if you are giving. Okay. So have a good day ahead. I am just leaving now. Thank you. Thank you so much for your patience. Yes, definitely you will get it. Just give me some time. I will preparing it. After preparation of that, I will provide you the exam.